Thanks very much for the invitation to present today. I'm excited to hear about everybody's work, and I appreciate the combination of being able to present remotely, and I'm really sorry to miss everybody in person, but hopefully we'll get to connect one way or another. So today I'm going to present a little bit on the strengths and limits of online studies, and I'll be focusing on one study in particular, one that my lab ran online. So online studies with infants and children are a relatively recent development that became newly urgent, as we all know, in the light of the COVID-19 pandemic and the suspension of our in-person research. So several questions I think naturally arise. Is there a difference between online and in-laboratory results? Are there comparative advantages or unique limitations of one context or the other? Can we ask new questions now that the space of inquiry has expanded? So to foreshadow the main message of my talk, I'll suggest that some developmental paradigms used with infants, even those that seem well suited to the constraints and goals of online data collection, may not yield results consistent with laboratory results that rely on highly controlled settings and specialized equipment, such as large screens, for example. But that doesn't mean that all online methods won't work, as we've just seen from Aaron, from some of his a more comprehensive look at the relation between online and in-person methods. And testing those paradigms online, the ones that we've been using for decades in the laboratory, I think is a necessary first step in creating robust tools and expanding the space of inquiry for developmental science conducted online. So in addition, that kind of testing may even reveal limits to developmental paradigms that are not specific to online testing scenarios, and that can thus inform better in-person testing as well, either in the lab or in the field. So Aaron also pointed to this wonderful Frontier special issue that has a large collection of articles on online data collection with infants and children, ranging in topics from how-tos to perspectives and opinions to empirical reports, as he mentioned. And in this issue, as well as in other recent publications, we've seen evidence of many online studies that have reported results that are mostly consistent with in-laboratory results, either using moderated video chat or the unmoderated approach. So many of these studies have nevertheless adapted things like forced choice paradigms with children or looking time paradigms with older infants and toddlers, like preferential or violation of expectation looking time paradigms. But there are fewer reports on some looking time paradigms used with younger infants, evaluating if they may be adaptable to online contexts and serve as a replacement for in-person laboratory testing. So the study I'm going to talk about today focuses on just one looking time paradigm with young infants, the change detection paradigm. And this work was led by my lab's postdoc at the time, Agata Bohinska, who's now at the University of Oslo. So we adapted 2 experiments with 7-month-old infants from a series of experiments on infant shape discrimination, which were conducted in a laboratory setting. And these experiments used this change detection looking time paradigm. So in this paradigm, there are rapidly changing displays, in this case, visual forms. And here we're looking at triangles. They're presented on both sides of the screen simultaneously. So on one side of the screen, in this case, there were triangles changing in area, in position, and orientation. On the other side of the screen, there was an additional shape change. So there was an area change too, insofar as the shape change came along with or correlated with an area change. So the rationale behind this paradigm is that if infants look longer at the stream with the one additional change, so in this case, the additional shape change, then that serves as evidence of their detection of that change. So in the laboratory study, we observed across 4 experiments that infants showed significantly more looking to figure streams that had shape and area changes compared to those that only had area changes. And in particular, we saw that detection in full triangles and in L or V-shaped figures that changed in relative lengths, the relative lengths of their sides. So in addition to probing infants' shape sensitivity, the change detection paradigm has been used to investigate a variety of infants' abilities in laboratory settings, including their sensitivity to mirror reversals in visual forms, to numerical differences in dot arrays, and to bound color and object information in visual short-term memory. So it's also been used in the laboratory to chart developmental changes in infancy. So for example, in numerical discrimination from 6 to 9 months, and in visual short-term memory from 4 to 13 months. And in addition, there have been small-scale longitudinal studies in the laboratory that have relied on change detection to measure infants' individual sensitivities to number and geometry. And these studies have revealed stable change detection across individuals in infancy and correlations between change detection in infancy and performance on standardized measures of symbolic mathematics in young childhood. So the infants would be measured at age 6 or 9 months, and then their math scores would be measured, say, at 4 years. So with the possibility that online testing will allow for larger sample sizes and the ability to collect repeated measures with the same infants over longer periods of time compared to in-laboratory testing, change detection becomes a prime candidate, I think, for supporting large-scale longitudinal studies focusing on development and individual differences across domains. This paradigm, moreover, offers additional scientific and practical advantages relative to some other looking time paradigms used with infants, like habituation, for example. So for example, studies using habituation to evaluate shape discrimination have relied on long presentation times, considerably longer than those that might be, than the presentation times or the times that infants look at things during everyday viewing, right? So change detection may result, moreover, in lower numbers of excluded participants. So there's no introductory period that might bore babies, right? They get straight into the experiment right away. And change detection doesn't rely on things like automated eye tracking or even live experimenters, right? Because there are fixed duration presentations. So this allows for offline coding, perhaps fewer research personnel, and even remote unmonitored data collection. In terms of the potential challenges for this paradigm for online research, most studies using change detection in the laboratory have relied on stimuli being presented on 2 separate monitors or on a very large projector screen, neither of which are typically presented or present in the home. Those that have relied on smaller screens have in some cases failed to find some of the same change detection capacities that were found with larger screens. And there's some unpublished data that suggests that change detection findings in the numerical domain measured in the laboratory may not replicate on these large screens, or sorry, on these small screens. So in our experiment, what we aim to do is directly replicate with direct in quotation marks, given these limitations of online studies, 2 of the experiments that were part of the original in-laboratory experiment. One in which we measured infant sensitivity to changes in triangle shapes, and one in which we measured their sensitivity to changes in the relative lengths of V or L shapes, okay, here at the bottom. And we adopted stimuli that were presented on Lookit. So these were unmonitored presentations to families who could join the experiment at any point which was convenient to them. They were walked through a series of instructions. In the first case, there were written instructions to parents, bullet points to follow. In the second case, we had a video, a set of instructions for them to follow. And the babies would watch these fixed duration trials, 4 blocks of trials in which the shapes would be presented for 60 seconds. And on one side, again, there was a change in shape information, the shape and area change. And on the other side, there was a change in area alone. So we just could measure offline from the video sent back to us how much the babies looked at each side of the screen. And this is how it sort of appeared on Lookit. Again, it was accessible to parents whenever they had a chance to participate. And the data came back to us in the laboratory. And just to give you a sense of the similarity between just the raw videos that were presented in the lab and online, here's what they looked like. The first video you'll see here is what the baby saw in the laboratory. This was projected on a 3-foot by 4-foot projector screen. The infant sat about 3 feet away on their parents' laps. And you can see here that the background was dark, right? So it was an otherwise dimly lit room with no distracting information. Online, on the parents' computer screens, we decided to use a white background, not knowing what the lighting conditions would be in the environment. We thought that the shapes might be more visible if we presented them as dark shapes on a light background. But otherwise, there are very minimal differences between the presentations. And in the second experiment, we compared infants' performance on Lookit to their performance online, to their performance in the laboratory when presented with shapes that were varying in their relative length relations. So I just played the video of what infants saw in the lab, and here's the version of it that was presented to infants online. Again, very similar displays. And here I wanted to just give you a sense of what data collection looked like from the other side, right? So You've seen that the stimuli are very similar when presented in the laboratory compared to when presented online. I think some of my videos of the babies in the lab aren't quite that still. I think some of those videos aren't playing perfectly. But the sort of overarching theme here, I think, is there is a lot more variability, at least in the contexts, the parent's behavior, the visibility of the baby's eyes or the baby's movements here on the look at side on the right, compared to the presentation here on the left. So what were our results? So in the laboratory, we only had sample sizes of 16. Okay, so each experiment was run with a set of 16 babies. We replicated each one though. So, you know, if we found a result with 16 babies, we replicated that one before we kind of pushed the paper through. But we did a power analysis based on the effect sizes of each of those sets of 16 babies. And we found that if we chose an N of 48, then we would have a 99.4% power. So we decided to sort of go with maximum power and included 48 babies, full-term 7-month-old infants, which is the same age as what we ran in the laboratory. Sorry, my video is blocking everything. I can't actually see. Okay, I can't. There we go. That's fixed. Okay, so the first thing you might be wondering, given the variability of those videos, is how hard or easy was it to code? And it turns out that actually our coders had pretty high reliability. So something that you might see in the laboratory, which is good news. So even though the videos seem like they're a little bit harder to code, that wasn't the case. So what about our pre-registered analyses? Basically, we pre-registered one analysis, which is do the infants online show the preference, the looking time preference for the shape and area change stream over the area change stream alone. And what we found is that unlike in the unlike in the laboratory study, there was not longer looking to the shape changes compared to the area changes alone. And of course, we wanted to follow up to figure out what the heck might have been going on there, right? Given what we thought was the similarity, at least in the actual visual properties of the stimuli. So we did some exploratory analyses. So the first analysis we did was just compare directly the results from the laboratory and online. And we found that the results were significantly different from one another. The next thing we wanted to know is whether infants at home were looking enough at the stimuli to actually be able to kind of get the information they might have needed to attend to the shape information. And it seems like they were actually, and this is kind of an interesting point. I don't know if folks have ideas about this, but infants in both of our experiments tended to look longer overall in the home experiments versus in the online experiments versus the laboratory experiments. So it couldn't have been the case that they actually just weren't attending to the stimuli enough. We did find in an exploratory analysis, looking back at some of the original work that was done on Look It, that distracting events come up at home, and these might be related to infants' performance. So we found in our exploratory analysis that the number of distracting events that infants had in their environment while they were being tested negatively correlated with their looking to shape changes. So not only to their overall looking, but also to sort of the main effect of the study, which was looking to these shape changes. And infants who had one or fewer distracting events showed a positive, although not significant, preference for the shape and area change stream. So in experiment 2, we focused on infants' detection of relative length changes instead of global shape changes. They're also robustly detected in the laboratory. They can be instantiated in simpler figures and may actually underlie infants' detection of global shape changes. So, and inspired by the exploratory analysis of experiment 1, we focused on distraction specifically as the cause of the difference between the findings. So we did so by improving some of the instructions given to parents and by introducing new exclusion criteria based on extraction with planned analyses that allowed us to evaluate the effects of distraction directly. Here we actually had kind of a Bayesian sequential analysis planned where we would include 8 infants and then another 8 infants and another 8 infants, but we never reached our criteria that would allow us to stop the study earlier than 48 infants, and that was our max. So we wound up with 48 infants again. There was still high reliability in the coding. Our pre-registered analyses, again, sort of basic analysis, did the babies look longer at the shape changes? We found that they did not. We also found that with the distracted infants included, this didn't change our results. So whether or not we had distracted or not distracted infants in there, we found no significant effect of shape changes. Now we can talk about some of these exclusion criteria and these kind of marginal p-values. I'm happy to talk more about that. But as you can see from the graph, it doesn't look like, or the Bayes factors, it doesn't look like an overwhelming response, even if there is sort of a marginal p-value. And the number of distracting events here did not negatively correlate with looking to shape changes in this case. And actually it was slightly in the opposite direction. Our exploratory analyses here again showed it was not a significant difference between the lab and online, but there were qualitative differences in the size of the effects. And again, we found more overall looking online than in the lab. So just to summarize, we ran 2 experiments on young infant shape discrimination for an unmonitored online testing platform, Lookit, and it didn't reveal infant sensitivities to shape information as had been revealed robustly in laboratory experiments. In particular, unlike the lab studies, we found no evidence that 7-month-olds looked significantly longer to shape changes in triangles, which was experiment 1, or relative length changes in V-figures, experiment 2, over and above these changes in position, orientation, and size. While the exploratory analyses of experiment 1 suggested that infants' failure to detect these shape changes might be due to their distraction, planned analyses in experiment 2 found no relation between infant distraction and their change detection. And so our findings suggest that other factors, instead of or in addition to distraction, may have instead affected infants' performance. So what could that be? So a change detection in particular relies on, so a couple of things. So the first thing to note is the small screens may have been a big factor, and in kind of a general way. So other studies that have aimed to replicate laboratory findings online have suggested that the salience of spatial or temporal information might be too subtle when presented on small screens. More specific to change detection, however, change detection relies on conveying that there are 2 discrete events being presented, with only one event displaying uniquely changing information that might draw infants' attention. And so small screens may make this important aspect of this paradigm more difficult to convey, especially compared to contexts in which change detection displays are presented on specialized equipment like large projector screens or 2 separate monitors, as had been done in most of these laboratory studies using change detection. So while this paradigm may have seemed ideal for adaptation to online testing in particular, because of its ability to yield reliable individual differences in longitudinal studies, its use to fixed duration, it may not be adaptable to online contexts or even other laboratory or field contexts if the testing in those contexts relies on small screens. So some developmental paradigms used with infants, even those that seem well suited to the constraints and goals of online data collection, may thus not yield results consistent with laboratory results that rely on highly controlled settings and specialized equipment such as large screens. So testing these paradigms online is a necessary first step, I think, in creating robust tools and expanding the space of inquiry for developmental science conducted online. So as the present study suggests, moreover, such investigations may also suggest limits to developmental paradigms that are not specific to online testing, right? That just may not have been recognized yet in the laboratory, like using small screens. So such findings thus allow us to further refine both sets of tools and better understand the context in which infants' ability can be reliably and robustly measured. Thanks very much.
All right, thanks, Molly. We might have time for 1 or 2 questions before we break for lunch. Does anybody have a question? Yeah, go ahead.
Did you measure the overall screen time that kids are having? So COVID-19 had a huge impact on the amount of screen time that a lot of kids had. And so I wondered if it's the case that they become more habituated to looking. And so the differences maybe got hidden inside of that. Did you consider that?
We did not look. Yeah, we did not ask questions about screen time to parents. We certainly could have done that. I think that maybe that would be related, if it were related to any of our findings, to this sort of overall longer looking in the at home versus in the laboratory. Screens are very interesting. Kids always see parents looking at screens. I know my 20-month-old is obsessed with my phone and my computer. That said, these were only 7-month-old infants too. So it's also a question about how much screen exposure they really could have had at this point, right? At only 7 months, and how much they may have affected any subsequent behavior. So I think with these really little ones, it's tough to say. We didn't ask that question, but perhaps it has something to do with their overall looking longer to the stimuli presented online versus in the laboratory.
Yeah, go ahead.
Hi, Molly. It's Brandon.
Hi, Brandon.
Super fun set of experiments. I was wondering, on the point about screen size, sometimes when I have parents participating online, they actually have it set up so that like their laptop's connected to their TV monitor, which is like a lot larger.
Yeah.
I wonder if you have any such parents or participants in your sample, and if you can, if you look like in an exploratory way, whether that might change things.
Yeah, thanks for that question. So we were not savvy enough in experiment 1 to ask about screen size, and we have only subsequently been doing that during our Zoom sessions. So we are at this point collecting data over Zoom, and we have noticed and collecting information about screen size. We've noticed a wide variability here. So we had one parent who had like a 63-inch monitor for some insane reason, right? And it was showing their baby the stimuli on that, which probably is very exciting. But we don't have the information to evaluate that. My sense from what we're currently seeing is that a lot of parents are presenting the baby with the stimuli on their 13 or 15-inch laptops. And that certainly seems too small for change detection, at least. But I don't know. I mean, I think this is something that we could get together and talk about. If other folks are having, have collected this data, we could all look at it together and sort of see maybe if babies are excluded less often when they're viewing stimuli on bigger screens or something like that. But we don't have that information, and I think change detection is going to outscale, the needs for change detection are going to outscale most of what would be possible for parents to use at home.
Okay, we have a question from someone who's viewing online that either Molly can answer, or maybe Mark, you might also know. If people using Lookit can get information about screen size
So I think no, and I think that maybe we should let the Lookit folks know that would be a great thing for us to be able to have. At least we couldn't, to my knowledge, when we were collecting these data. So we were an alpha and beta tester for Lookit. So some of these data, especially experiment 1, were collected in 2017 and 2018. So maybe that's a feature that is available now, or maybe it's something that we can help brainstorm a way to implement so that we can get that for future studies. But Mark,
great.
Yeah, I would just like to add to that so screen size is only one of the dimensions. You really also need to know viewing distance to calculate degrees of visual angle to compare, apples to apples, and that would be great. I don't know how to do that, but probably some creative experimentalist can figure out how to collect that in a home setting. That would be awesome.
All right, great. Okay, so Molly will be rejoining us for the last session of the day. So if anybody has more questions for her, we can wait till then. But for now, let's thank Molly again.